morning. Here now we are just going to see the topic of basic concepts and identifiers. In this, the introduction is the brief history of Verilog HTL. That is, in 1985, the Verilog language and related stimulators Verilog XL were developed by the Gateway Automation. Here, the Cadence Design system purchased Gateway Automation, that is in the year of 1989. Here, the Open Verilog International formed in the case of 1990. Here, 1995, IEEE standard 1364 is been adopted, and the features of Verilog HTL is it has the ability to mix the different level of abstract freely, one language for all aspects of design testing and then verification. Here the Verilog HTL is like verifying the logic HTL and the hardware description language, that is HTL is nothing but hardware description language, a programming language that can describe the functionality and timing of the hardware. Why use a HTL, that is hardware description language? It has becoming very difficult to design directly on hardware. It is easier and cheaper to different design options. Here it is a reduced time and then cost is very less here. Then this programming language versus Verilog HTL, that is we are just comparing whether it is similar or so many things are different in this case. In this programming language, if this A is greater than B, you will be get a code, and if the A is not greater than B, and you will be get a piece of code. If it will be goes to a compile part, and here in this case .asm file is been assembly language code, that is it is been developing, and after that it goes to the CPU, that is the computer. And here the Verilog HTL is if A is greater than B means it begins and then ends, and in the case it goes to the synthesizer and to the logic circuit. Here in this logic circuit you will be getting the value of I0 to input, that is 0 to n, and it goes to the CPU and it goes to the block. And next one is the different level of abstraction. Here the Verilog XL is an event driven simulator that can emulate the hardware description described by Verilog HTL. This Verilog HTL allows you to describe the design at various levels of abstractions within a design. Here in this case, this behavioral level, RTL level, and then gate level, and then switch level. These are all the different level of this behavior. And here the different level of abstraction is the architecture, that is, or else the algorithmic, that is behavioral, a model that implements a design algorithm in high level language construct. A behavioral representation describes how a particular design should respond to a given set of inputs. Here in this case, the register transfer logic, that is a model that describes the flow of data between registers and how a design process is data is doing in this data. And the gate level, that is the structure, is a model that describes the logic gates and the interconnections between them. The switch level is a model that describes the transistors and the interconnections between them. The three level of Verilog HTL is like gate level, switch level, and then behavioral level. In this gate level, we will be getting the value, coding of like XOR, U0, and so on. In this switch level, here it is AND gate of U2, that is VDD, NAND A, and then B, and then wire 1, wire 2, that is it is the switch level, and we have to give the each and every connection of this one is switch level. In this behavioral level, it is all based on your coding part, that is assigning CO, sum means you will be getting this values here, will be getting the values here to get the output over in this behavioral level. And the next one is Verilog HTL simulators. Here these are all the list of simulators which has been used like VCS, Model Sim, NC, Verilog, Verilog XL, and then other simulators like Max Plus 2, and then active HTL. The Verilog module includes the following parts, that is the module name, and then the port declaration, data type declaration, and then task and function declaration, module functionality or declaration timing specification. These are all the assessment questions. Why use an HTL, and why name the module ports, why model sim is used compared to other simulators. Thank you.